Hello everyone and welcome back to Nunley Math. Thank you so much for joining us here today. I'm Aaron Nunley and we are now well into our unit on expressions and equations. We actually just have a couple more items to talk about. Today's lesson should be just a little bit shorter, I think, because we're going to be building on ideas that we have already learned. So there's not a whole lot of new stuff in here today. I'm just going to show you one or two new things and then tie it together with some stuff you already know, and hopefully that is going to be sufficient. So we're solving equations with variables on both sides of them, and we're still using the properties that we've been discussing in the previous videos. At this point, you should be fairly familiar with these, so I don't feel it necessary to go through and read them all again, but you are certainly welcome to pause the video and do that if you need a refresher. If you need an explanation of these in detail, I would recommend that you go back and watch the prior lessons in this series. Here's an example of a problem that you might have seen in our solving multi-step equations lesson. Notice that over here on the left you have a lot of things happening, but it's equal to 30 on the right. Over here on the right hand side, I've given you a list of steps that I like to use when I'm solving these problems, and I would highly encourage you to use as well. You will find that there are different orders that you can solve equations in, but I find that the students who are consistent in the method that they use tend to make fewer errors. Speaking of making fewer errors, you'll notice that I'm starting here with the definition of subtraction. Losing track of minus and negative signs is one of the biggest errors that students experience all year long. So I encourage students to be very cautious and conscientious when dealing with their minus signs. I like to take my minus signs and turn them to adding the opposite, because for two reasons. Number one, it does kind of emphasize the fact that you need to be careful with those minus signs, but additionally, it makes it easier to use the commutative and associative properties later on. So I use the definition of subtraction. I've changed those signs. I'm then going to use the distributive property to get rid of these parentheses. Distribute the 5 to both of these, and then I'm going to use my commutative and associative properties to rearrange and regroup. Now, in the other lessons, I spent a lot of time separating these into two steps, but at this point, you should be getting pretty good at that, and you can begin to combine it into a single step. Notice there's nothing to rearrange here, so I just use the associative property to regroup. I put my x's together and get a 22x. That's the distributive property. I take my negative 20 and my negative 16 and put those together and get a negative 36. That's just a little computation. Now we have that very familiar two-step equation pattern. Once you're at this point, you can use the property of equality to do whatever you want to both sides. I picked a plus 36 because I can see that negative 36 and plus 36 are opposites, giving us the 0. And I know that adding 0 doesn't do anything. So I use the property of equality, I perform my computation, and then I use the identity property to get rid of the 0. You'll also notice that I then have a single step equation, which should be a very familiar pattern to you. I use the property of equality, perform some computation, and then use the identity to get rid of the times 1. Once I know my answer, I can check the problem by rewriting the original problem, plugging in the 3 or substituting the 3 in, and then just using order of operations to simplify until the sides match. If the sides match exactly, you give it a check mark. You know that your answer must be correct. If the sides don't match, you've made a computation error or some kind of an error earlier in the problem, and you do need to go back and fix that. One thing I should note, you'll notice back here that when I had my associative property regrouping things, I did get the 22x, but see this plus negative 36? I did rewrite that as a minus 36. Once we're back in a two-step equation, it gets pretty easy to keep track of those negative signs, so often you'll see me switch back and just use subtraction at that point, but you definitely don't want to use it at the beginning. Again, this is all review. I don't want to overinvest our time in this. But if you're struggling at this point, you really need to master this by going back and watching those other videos before you move on to what we're talking about today. So let's go ahead and look at that. 7x plus 9 equals 19x plus 54. This equation is different from all the ones you've seen so far. Do you know why that is? If you need a second to pause the video and think about it, please do that. I'm going to go ahead and assume that you found the difference or that you've given up. And I'm going to go ahead and tell you that it's because we have an x on both sides of our equal sign. We have an x on both sides of our equal sign. Now, the good news is that might catch you off guard a little bit, but it really doesn't make the problem much more difficult than anything we've already been doing, because the property of equality allows me to do whatever I want as long as I do it on both sides. So when you look at this problem, can you think of something that you would like to do? Here's a thought. A lot of you might have said, hey, I have an add 9 or a plus 9 here. If I subtract 9 from both sides, that would give me a 0 over here on the left side. And that would be simpler, and you would be correct in saying that. But that's really not the only option of what we can do. Can you see something else? Hopefully you've realized that you could subtract 54 from both sides, because 54 and negative 54 are additive inverses or opposites, and that would give you a 0 on the right side, and you would be correct. But those are not the only two options for what you can do in this problem, because the property of equality says I can do whatever I want as long as I do it on both sides. So if I wanted to, I could subtract 7 x's from both sides. That's new and different for us. We've never moved x's from one side to the other, but think of it. If this x was a 1, 7 times 1 would be a 7, and I would be subtracting 7 from both sides. If this x was a 2, we'd have a 14, and I'd be subtracting 14 from both sides. If x is a 3, this would be 21, I'd be subtracting 21 from both sides. The point is, just because I don't know what the value of this number is, it doesn't mean that I can't move it. I can move it as long as I do it on both sides. So I'm moving the 7x's knowing that this is a number that I just don't happen to know yet. But again, that's not the only thing I could do. If I wanted to, I could subtract 19x's from both sides. For the same reason. If x was a 1, I'd be subtracting 19 from both sides. If x is a 2, I'd be subtracting a 38 from both sides. Just because I don't know what the number is doesn't mean I can't move it. I can move variables in the exact same way I would move numbers. I'm actually going to do it this way because I know 19x minus 19x is going to give me a 0. I know 7x minus 19x is going to give me a negative 12, and I just bring down the plus 9. And I bring down the 54. Remember, we use the property of equality. We also just did some computation, and we also used the identity property. Notice I did not write the plus 0. As you get better and better at this, that's a step you can begin to leave out. One of the reasons why I moved the minus 19 instead of the 7x is if I had subtracted 7x from both sides, my x's would have been on the right side of the equal sign, and I just don't like that. Some of you may not care either way which side it's on, and that's fine. If you wanted to move the 7x first, you certainly could do that. Additionally, there's no rule that says I have to move the x's first. I could have done the minus 9 and the 54. But remember what I said on the previous slide. If we have a pattern that's familiar, it's often good to stick to that pattern so we make fewer mistakes. When I move the x's first, I get this very familiar two-step equation pattern. I should be able to solve these almost in my sleep now. Property of equality says subtract 9 from both sides. Computation is going to give me a 0 here, and a 54 minus 9 is 45. Notice I performed my computation, my identity at the same time that time. I did not write the plus 0 because we know it's going to go away anyways. When I finish that, then I'm going to go ahead and do the property of equality again. And then I'm going to do the computation and the identity. I'm not going to write down that times 1 anymore. I'm just going to leave it as x. 45 divided by 12, I went ahead and made this into a mixed number. This would go in 3 times and be 36. This is negative 3 and 9/12, which is negative 3 and 3/4. Notice again, we use that equality computation identity pattern twice towards the end of the problem. By moving the x's first, I create something that's familiar, making the rest of it easy to solve. Big idea for today. The property of equality can be applied to numbers we don't know. We refer to those as variables, just like numbers we do know. Those are called constants. Do you want to do that again? Let's do it again. I can use the property of equality here. This time I'm going to go ahead and move that 11 and do minus 11 from both sides. And I'm going to get negative 15 equals 6x plus 4. Now, a couple things I want to point out. The last time I moved all my variables to the left side. This time I'm moving them to the right side. Do you know why I'm doing them on the right side this time? Well, if I had done this the other way around and I had subtracted 17x from both sides, I would have got a negative 6x over here on the left, minus 15 equals 4. I like negative x's even less than I like having my x's on the right-hand side. So I had to make a choice there. Again, it doesn't matter which one we move. We're going to get the same answer either way as long as we don't make a little computation error elsewhere. I would suggest moving the one that looks like it's going to be easiest for you. Notice we have that familiar two-step equation pattern. That should make this a little nicer for you. So we use our property of equality. We're going to perform some computation and the identity together. Remember, we're not writing the plus 0 down anymore because we know the identity property says we don't need it. I'm then going to use division. I'm going to divide both sides by 6. That's the property of equality. And again, I'm going to use the computation and identity together and get negative 19/6. Notice I've done two things here. 19/6 is 3 1/6 as a mixed number, and then I use the symmetric property to switch which side of the equal sign things were on. Remember, the symmetric property says that if two things are equal, they're equal regardless of which side of the equal sign they are on. Again, equality, computation, identity, equality, computation, identity. The property of equality can be applied to numbers that we don't know the same way they can be applied to numbers we do know. I do have one more example that I want to show you. You'll notice this one's a little longer and more complicated because you have a long expression or a multi-step expression here on the left, as well as a multi-step expression over here on the right. We're actually going to do the exact same thing we've been doing, but we're going to tie a lot of loose ends together. So what I'm going to do is I'm going to split this into two separate expressions. I'm going to work with what's here on the left and simplify it. I'm going to work with what's here on the right and I'm going to simplify it using the exact same process as we use when solving multi-step equations. Meaning, I'm going to use my definition of subtraction and I'm going to get rid of the minus signs. Minus 2 becomes plus negative 2, minus becomes plus negative 1. And then I'm going to use my distributive property just like I always do. I'm going to give that negative 1 out to both. I'm going to give that negative 2 out to both. And we end up here. Once I've done the distributive property, I'm going to go ahead and do the commutative and associative properties, and I'm going to rearrange and regroup the like things together. Notice that 5x and negative 3x are already together. Notice negative 7 and 4 are already together. As I get better and better at this, I tend to do more of the commutative and associative properties in my head, and just know that 5x and negative 3x make a 2x. Negative 7 and 4 make a negative 3. I'm then going to do the same thing over here on the right. Again, I'm looking for things that are alike. Ordinarily, I would rearrange those, little star there, regroup those, and combine my like terms. But instead, what I'm going to do this time is I'm just going to say, okay, I know the negative 2x is going to be here by itself. I know that if I rearranged and regrouped, I'd have a 24 and a 3, and so I just use circles to help me spot those things. Again, if it's uncomfortable for you to do all three of these things together, you are certainly welcome to split that into multiple steps, but hopefully you've had lots of practice as we've been going along, and that's getting really easy for you. Once we do that, notice we have that familiar pattern where you have an expression on the left, expression on the right. The left side's a variable and a number, the right side's a variable and a number. I can use the property of equality to move any of those things I want. I'm going to go ahead and add 2x's to both sides. Remember, when we add 2x's to both sides, those are going to become a 0, and we're going to get 4x plus negative 3 equals 27. Now notice I did the property of equality, I performed some computation, and I used the identity property to get rid of the plus 0. As I get better and better, you're going to notice that I'm not writing those things over here as much. We're just remembering that they're taking place. This time I happen to do all three at once. Now I have that familiar two-step equation. I'm going to use property equality, do computation, and my identity gets rid of the 3's. Or I should say the identity gets rid of the 0 because we had opposites for our 3's. Again, property of equality, a little computation. Notice I used the identity property. I did not write the 1 down, and you get x equals 7.5. Again, my suggestion to you is that you simplify each side separately first. Get them in as simple a form as you can, then use the property of equality on the variables, and then finally use the property of equality on the numbers. That's all we have for today. Hopefully that has been useful for you. I do appreciate you taking the time to tune in. I do wish you all the very, very best of luck. You all take care of yourselves, all right? Bye-bye.